Hey Sam, how are you?
Oh, hey, how are you?
All right.
I think we talked before, right, in Slack?
You were chatting about mock.
Yeah, yeah,
Yeah.
okay. Yeah, the name ring a bell.
I am trying to see if there's anybody who can merge here. I don't have merge privileges in the AI working group repo, and there's a few folks who put their PRs up. Hey Pascal. Pascal, do you have merge privileges on the AIWG repo?
Maybe.
Oh, hi Kitty. What's your cat's name?
This is Toffee.
Oh, hi Toffee.
Hi.
There's also a
Hey,
mochi,
Thor.
like the food, or both.
I want some toffee.
You can imagine the nicknames, right? Yeah, but they're suffering in this heat now. It's too hot.
Yeah, it's incredibly hot. Yeah,
Especially because
quite heat wave. Yeah.
Europe is not built for this. At least, I mean,
Yeah.
our our part
Close to
of Europe.
40 over there, right? Something like
Yes,
that.
yes, yes. It's close to 40. Yeah, it's like 37, 38 currently. Yeah. Yeah. So there's no air conditioning here. Yeah, it's the
Yikes.
difference. Yeah.
I'm sorry.
Okay, so then much stories.
Hey, everybody.
Jeff, did you fix the table?
I did.
Do you
I
also
didn't know
have
I'd be
have
causing. I don't know if I'm causing merge complex.
no, it's
Sorry.
all good. I'm the same. Like if the table is not right, I have to fix it. I do exactly the same.
Not to flex or anything, but I did that by hand in the GitHub editor.
Oh yeah, of course.
That's
Another way of doing it.
spacebar.
Um, I think we have an issue.
Uh-oh.
Because our CLA goes to the committing um, offer, Raimi, and your commit is not from your account. This leads to complications with the CLA bot. I'm not sure what to do to be compliant here, but I can, of course, fix the pull request so that it's at least green to merge.
You are muted. Oh, yeah, there we are.
But you said it's not from my account?
It's from your account, but the committer's ID is not linked to your account.
I see. But this is the whole
Or this the CLA wasn't
yeah, like
signed for this user or something like this.
I see. So they have my Airbnb account probably as a CLA. Oops. Huh. All right. Let me just do a new CLA for the future.
Okay.
That's interesting.
All right, well, while we're doing this, should we kick off? Or do we need to?
Let's do it.
Get our participant list. Yeah, I think we should, right?
I believe, Tori, you're host today, right?
Not that I know of.
Not that you know of. Okay, then did Quade reach out to any one of you? Because otherwise I'll just do it. 1 second.
We yield to you, Pascal.
Okay. Okay. Then I'll do it. Don't you worry. Let me open the repo quickly. So it's less of a mess. No agendas. Oh, we already have 2026, I see. It's wild. Okay, then let me share the screen. Do you see something?
Yes.
Fantastic. Okay, so welcome to this week's or this month's AI working group. Quay is not here today. And I think am I in the right one? No, I'm in the wrong one. No, it's the right one, 25th of June. Okay, so Quay is not around today, so I will do the hosting for her. By being here, we all agreed to the membership participation and contribution guidelines and also the code of conduct. Also, a reminder, these meetings will be published on YouTube, and we will use LM and AI summary tools to summarize this. And we'll start with a round of introductions. I just see that I'm missing in the agenda. Great. In the order of the attendees. So Dale, stage is yours.
Dale, could you intro yourself?
Hi guys, sorry.
Nice.
My name is Dale. I'm from Apollo. I work on MCP server and skills. I'm from Toronto, Canada. Nice to meet you, everyone.
Next is Samuel.
Yeah, hi everyone. I see some familiar faces. My name is Samuel. I work for Expedia Group. I'm part of the API platform team, specifically the GraphQL platform. And over the last couple of months, we've been trying to incorporate AI and everything that it's surrounding it around the API platform to build tools for the product developers that consume more GraphQL schema. Nice to meet you all.
Then next is Michael.
Hey everyone, I'm Michael Rubello. I'm on the GraphQL team at Airbnb, and I live in San Diego, California.
Yeah, Jeff.
Hey folks, Jeff Oriama here with Apollo as well. And I am joining you from Monroe in the state of Connecticut in the US. Thor?
We have Tori.
Yeah, hi everyone. I'm Thor. I'm from Cologne, Germany. Yeah, software engineer and machine learning mostly, but yeah, part of the AI working group for some time now.
Fantastic. Is anyone else on the list that is anyone else in the calls which isn't on the list? Oh, Rainy.
Yes,
Yes,
I'm
sorry,
here.
Rainy, I forgot.
Yeah,
We just go out there and talk to each other.
I'm debugging my problem. I used the wrong email address, but Remy Seda from Airbnb in Palo Alto, California.
Then we have 1 second. Selko.
Hey,
Selko?
Jelko. Hey, yeah. I created a PR. My name is Jelko. I'm Croatian, but I live in Dublin, Ireland. I've been included in the latest cohort of GraphQL ambassadors. I'm independent, but I work mostly on JVM, Java mostly. Yeah, that's it.
Okay, I have just updated your pull request, so this one will be merged in a second. Anyone else in the call? Fantastic. Okay, I'm Pascal. I'm joining from Zurich, Switzerland. I will add myself to the agenda in a bit. I'm working for Chili Cream. So now this is done. We will determine volunteers for note taking. If not, we just rely on the AIs to do the right thing. Any volunteers, then there is a link in the agenda that you can open and you can type your notes. Now, review of the agenda. This we have all done. And then we check if we have anything from the past work group. And then we check what we have on this agenda. Now, I'm pretty sure I have added something, but I have no idea to which agenda because apparently it's not here. So I need to figure out where I've added it. But I actually have something to talk about. So I will take 15 minutes to talk about semantic search and the benchmarks that we now have. Yes, exactly. Semantic something. Does anyone else have something to talk about?
I do. I have something that I think I have shared before with some people in this call, but not in the AI working group. But it's related to mocking GraphQL responses with GenAI and something that we work on as CLI. So I would like to present that.
Right, we can do this. 1 second. Let me just refresh this. Now I'll update the agenda. Did I not merge? Why is it so difficult today? Okay, so this, okay, this goes. Format merge. Okay, agenda is up to date. I don't know. GitHub is broken today. Anyway, let's do it without GitHub. Okay, so as said, I have no idea where I've added it. Maybe it's in, I don't know, June 25, although this work group has not existed then, so I have no idea. Maybe I've added it to July. I don't know. Anyway, so we have a benchmark for semantic something now. And this is this benchmark here. There is a disclaimer at the end that a lot of this is created at the end. Yes, here, a lot of this is generated by AI and not peer-reviewed line by line, because it's a lot of content that goes in here. And essentially what we do in here is we have a benchmark that validates different, or you can validate different things. You can benchmark against different there's different benchmarks for different parts of semantic retrieval of schema coordinates or semantic search related to GraphQL. This benchmark exists because we didn't have an eval, and we somehow have to know how well semantic something or semantic search and semantic introspection work. And also we didn't really have a way to measure what the best templates is for semantic retrieval, because it depends like how well you're able to search something depends on the template that you embed. And in the templates benchmarks, we essentially validate different templates. For example, when we have the coordinate description, only the coordinate, when we also include the just the name or the signature and so on. And then these benchmarks run. Essentially, they run embeddings with a fixed model and with a fixed strategy. So it's pure KNN. And then we just run the benchmark and we get out how well these different templates perform compared to each other. We have two benchmarks. One is for the field retrieval and the other one is for the type retrieval, because depending on what you do in semantic search, you either need a type or you need a field or you need both. And with this, you can essentially add your own templates, and then you can run the benchmarks again. And when you want to add the template, you essentially just add it here. You rerun it via the CLI, which is all in the documentation up here. And then essentially you can rerun these benchmarks. So insights that we gain from this is that we now see that like a coordinate and a description is most likely, or what it looks like, the best way to retrieve the coordinates based on semantic similarity. Be creative. You probably will find something more or something better than this. This really is just very, very simple templates that were used here. I've used these results to decide what we use for the strategies benchmark, which I'll show in the end. We also benchmark different models. So what we now have fixed is the template, and we have fixed the not the strategy, but we have fixed the test data. And now what we do is we have fixed the strategy, but we have fixed the strategy. We have fixed the template, but we haven't fixed the model. So now we can benchmark against different embedding models, and we can see how well they retrieve compared to each other. Tori has already opened a pull request where he runs his Qwen fine-tuned model against the OpenAI small and large ones. And this already is very promising because his 1K parameter model is actually better than these two, which is quite good. Do you want to add something to this? Sorry.
Yeah, I don't know, maybe can show it later. So it's mostly fine-tuned on the field level. So on the field level, it performs a bit better. So it's quite small. So it has 600 million parameters, self-hostable. So yeah, it is difficult to determine like the real size of the OpenAI models, but yeah, it's specifically fine-tuned for this case. I mean, it can still be improved, I think, also on a recall on the type level. But yeah, I think it's a different benchmark, and yeah, just promising to see for now. Yeah.
Yeah, but you have 1K dimension vectors, right?
Yes, exactly. So 1K is the output dimension. Yes. So the output dimension is also quite a bit lower. I think it's like here it's 3,000 or something for the large.
It's 1.5.
3,000 for the large, yeah, and 1,500, yeah, for the small. So it's quite a lot of smaller model actually. Yeah.
Yeah, this is what I tried to say before. It's actually quite nice that you have a lesser dimension model which performs better.
Yeah, because we don't have any insights how large those models are from OpenAI. You only have the API pricing, so it's like hard to compare on like relative model size. But yeah.
Yes. So what do we train this? What do we run these benchmarks on? Essentially, we have different schemas here. We have the GitHub schema, the GitLab schema, the linear schema, the Shopify one, and the Singapore one. The Singapore one is the one from my talk. This is where I started, and then essentially I've added these schemas to the benchmark. We also need test data. This test data is largely generated. It's verified through different test runs across everything. I haven't gone through all of the 800 files here to verify if all of the queries are correct. But you will see in the end that at least most of the stuff in here is probably somewhat correct. We have 800 at the moment of these files. This is a user request that we have in here, which is specific to a schema. We have an ID, and then we have an operation, which is an operation that is defined to return the data. That's essentially the golden operation that answers the question of the user. We then extract the must include fields and also the target and target types and target fields. These are the fields which we want to use in the field recall, and these are the types which we want to use in the type recall. The must includes are used for benchmarking different strategies. And then we also have an answer schema, which is used in the agents benchmark. All of these 800 files have this in it. -KW stands for key value keyword, because there we essentially have just keywords for the same to run benchmarks to see if keyword search is actually better than just normal natural language search, or if natural language search is better than the other. Anyway, so we now have a set of these files which will be checked into the repository, and if you need to run any benchmarks, you can use them, and over time they will improve, and our suite will improve for this as well.
But
Now,
how do you validate? How did you validate this? Like, why do you think these are the right answers?
I don't know if they are the right answers. What I can say is that I've ran like hundreds of benchmarks on these files. So I've gone multiple times through them with all kinds of different models. One thing I can say is that the reason why I think it's validated that they at least execute is that all of the GraphQL servers that we have here, all of these schemas are executable and they're fully mockable. So there's a mock server for all of these schemas in this pull request. And what we do during the agents benchmark in the end is we actually execute. So what we do know is that executing the query actually returns data and deterministic, and with an LLM, we can determine that what the data that was returned is most likely the data the user wants to see. Again, if we want to be 100% sure, we have to go through all of these files. We have to validate them, of course, and see if it's really the answer that we're looking for. But this is more to get a bit of an understanding of where we're at with semantic search.
What do the percentages mean in the results if we're not sure
which ones?
what the right answer is? It was the chart you had that was comparing. Yeah, this one. So like, what does that percentage mean if we don't know what the right answer is per se?
This means that in 47.3%, it was in the top K20. The field that we search, and in the top K50, the search was 60% successful. So essentially, we do a needle in the haystack search. We say that we want to search for this this coordinate, right? And then we say that we take one of these queries here. Sorry, not this ones. We take one of these, take the question, embed the question, do a search, and what we want is these three files. And in 20% or in whatever percentages it was these fields that we were looking for were in top K20, top K50, top K100, top K200. So the first 200 that we have, the first 100 that we find, and so on.
So some model decided like these are probably the fields that we want to query for this query, and then ran it against that.
Yeah. Yes, exactly. Yes. That's exactly how it works. And then we essentially just run these against different embedding models. Same here with the embeddings, the embedding templates. Now, why does this exist? It exists because we couldn't answer the question how well semantic search works. Semantic search is something that we have built for or discussed after the graphical comp as an extension of semantic introspection, as an alternative of semantic introspection, which doesn't use introspection at all. And what semantic search does is it essentially generates an on-demand subschema based on a question of the user, which should include all of the coordinates that the LLM needs to answer the question of the user, which means that we include the relevant coordinates plus all of the information the LLM needs to build a query to execute. And this sounds like simple, but it's actually quite interesting what steps are involved to get something useful out of this. Because it's not only like if we say that we find top K, if we have a model that finds in 50% of the cases the fields in top K50 or in the first 50 results, we don't necessarily have the same result when we do the semantic searches, because it could be that we are missing the wrong query field and we never get to this field on this type. And what this does is it's a set of algorithms which tries to expand the schema semantically to get a schema which fits the user's query. So includes all of the coordinates that the query needs. And this is all that we have here. So from the query, so based on this golden operation, we have query repository, default branch, target, and so on. And from there, we go essentially deeper, and then all of these coordinates are in the must include. Now, results. We have a lot of implementations here of these strategies. They are all in here. And an interesting result. So essentially, what this is started to be optimized to is having the smallest schema possible that includes all of the coordinates required to answer the question. That's the optimization that we are working towards. And after running hundreds of benchmarks with different algorithms and different optimization, this one is the slicer is quite an interesting algorithm. The slicer essentially gets through all of our 816 test cases. In 90% of the cases, all schema coordinates into the subschema that it needs to execute or to have enough knowledge about the schema to build a query. And it does this with a mean, I believe, of 10.7K tokens. And I think, no, 11K tokens. P50 is 10.7 and P99K tokens is 23.3. Now, what does this mean? It means that we take a schema which is 140,000 lines, like the linear schema, and then we break it down, and or the GitLab schema here, and we can now answer a user question in just 16,000 tokens. So we don't overload the context window of the model, and we save also input tokens. Because essentially, we don't need all of the schema to answer a user's question, so why should we include all of it? And theoretically, this model should scale that even if your schema is, I don't know, 16 million tokens, like Facebook's, then it will maybe return a schema which is consumable by an LLM. That algorithm essentially, it's not a link. What it does is it first does, in the end, we ended up with an algorithm that does a similarity search, top K of fields, then includes the types of these fields in the type retrieval sets. And from these types, then starts to expand the schema like a topology, and includes parents and childs, which are semantically relevant to the user's question. And in the end, we have we essentially do in parallel, we start expanding these things, these subschemas, and in the end, we take the subschema which scores the best, and this is what we return as the subschema. And if we take this and we put this into the next benchmark, the agents benchmark, then we see that we can actually, with GPT 4.1 mini and across half of the benchmarks here, we can answer the user question in 85% of the time. And what this means is that in this benchmark, we actually have we use the chat API of OpenAI, and we have a conversation with the model, and we give the model the answer schema that we have defined here, and we give the model a function, a method that can generate the subschema, and we give the model a fully functioning mocked server, and then it's on its own. And essentially, without any further user interaction, it has to understand the user question, do a semantic search, get the subschema, then either if it's enough information, consume the build the query and execute the query, or get more information with the progressive semantic search, and then build a query, execute the query, take the answer, and answer the question with the second function, the answer function. And this works with GPT-4.1 in 85% of the time with the data and the tests that we have here. Of course, not really verified in detail. I didn't went through all of the 800 queries, but from the samples I checked, this seems kind of legit. Now, we can have a more expensive model here, and the results get a bit better, but also it gets a lot more pricier. This run over 408 models already costs $5. But like on a case-by-case basis, this is super cheap in the end. And it's quite a, like, it's not a frontier model, so you don't need Opus or Sonnet for it. You can run GPT-4 Mini, and you can get the answers to your questions. Yeah, so this is for people which are interested in building semantic search themselves, which are interested in how well this performs, also with bigger schemas like the GitLab schema. If you have ideas how your algorithms could work to build subschemas, if you want to benchmark how well semantic introspection works, if you want to benchmark whatever, this is a suite of things that is available for you to use and maybe gain new insights. Any questions?
How many turns were this? Like 3 turns here in the P50, right? Like turns of semantic introspection.
Yes.
Yeah.
Means so it's not semantic search, right? And
semantic search. Okay.
This is just turns to the LLM. Essentially, first one. So the first one is the search call. Second one is the query execution,
okay.
And third one is the answer.
This would also be interesting, maybe to group by if the query would fail, if it redo the query again, or like how often it would have searched, or how often it would try to guess the query. Maybe. Okay, there it is.
Yeah. So we have the mean invalid is 0.6. I would need to plot it differently to have more insights, especially most of these numbers would, if we would have to plot these differently to get more insights. Essentially, what I've optimized for in the benchmark is to get this higher based on the quality of the data set that we have and the algorithm that we have. Yeah, so The model GPT-4 one still guesses wrong, and the model still exceeds budget sometimes. There is definitely also questions in here in the sample data which are not answerable by the schema, or questions which are too complicated to answer. There's questions in there which are multi-turn, so you actually need to write more than one query. Or maybe I have removed them because it was too complex to build into the benchmark. I can't remember. It's been a while. Yeah, so if you are interested into like make your own, Tori, and then you said that you have ideas how to plot it differently. Maybe it's interesting to see what insights you gain there.
Yeah, because I want to ask like what is the maximum allowed turns the model can have? Because like theoretically, if the model can have infinite turns, it will eventually find the result, right? So I mean, there is probably a hard cap on how many turns it can make, right?
Yes,
Because it's the agent run. Yeah. Okay.
I believe we set it to 12, and
Okay.
then it's gone. Okay. Cool. Then, if no more questions,
Pascal, this
Yeah.
is not a question, but I've been building something similar. So I shared the link in the chat. So I'm a like visual person, so like I built like a playground where basically just to help me to compare like different vector like embedding models, and also compare like different strategies to index index schema using BM25. And also I like my goal is to get the best balance between BM25 and semantic search. Like what I'm learning is that like they have their own strengths and weaknesses. So, but I was very impressed by how like a thorough and in-depth your benchmark is. So maybe like we can collaborate on
Sure. So this is exactly what is intended with this pull request. So you can there's like this is intentionally built in a way that you can just take your algorithm and you can plug it, and then we can run your algorithm against my algorithm. And we can that's exactly what happens already with Tori's Qwen model, right? Now we can gain insight. What's the best way of doing this? And you can also run the agents with your embedding models, with your search models. So that's all possible now. So please go ahead and do whatever you want to with this.
Yeah, sounds good.
Compare notes.
Yeah.
By the way, I played around with BM25 in this as well. And I had mixed results. Funnily enough, as said, most of this is more me having ideas how we could optimize this, not me writing an algorithm. It's more like we could maybe find a better similarity score if we do this or if we do that, and then start optimizing the parameters through benchmark runs. It's not like engineering an algorithm. It's more like trying to, from the outside, black box turn the knobs to get something out of it. And what I found in this kind of research is that LLMs are very, very likely to come up with the same solutions over and over again. And they also purposely try to lie to you. So even if you tell them that you want A, they might secretly do B until you look at the code. And then you're like, dude, I actually told you that I don't want it like this. So in this, I would say I don't know how well in the end I went back to more cosine similarity stuff and away from the BM25 boosters. But let's see. I also had a chat with someone I met at the Graphical Conf, which is also very keen on sharing their take on it. And they also use BM25 and have a pretty cool algorithm to do semantic search. So I think it's going to be interesting weeks ahead.
Yeah, sure. Yeah, I share the URL in the chat. Yeah, in case you guys are interested to see the
Nice.
playground.
Nice. I started with something simple, similar,
Yeah.
and then I
Okay.
had so much in the UI that I thought now I need to go CLI. But that's great. That's
So
great.
I started from the UI. So
Yeah.
yeah, because I'm like a visual person, but I don't think it's covering as much as you did in the benchmark. Uh,
Again,
yeah,
like
and yeah.
it's not. I am 100% sure that someone which builds an algorithm from scratch will get a better result. This is more to get the direction into what how in what direction we probably should look for, right? That's cool. I will bookmark.
So when you ran the benchmark, did you run everything locally, right?
Yeah, so I use only OpenAI models, but I used cheaper models. So I did not run the frontier ones. OpenAI 4.1 mini is the one which I ran the whole solution multiple times on. I tried to recover a few results with GPT-5. But like the price explosion is insane. Like you pay so much more if you take a better model. And I think in the end, where we have to go is we have to come to a place where we have a very efficient, well fine-tuned model, which most likely should run locally, which does a embedding and then another model which does the query generation, right? So that these connections are done correctly.
Okay.
I
Yeah,
will be
like
very
oh, go ahead.
sorry, I was gonna say like I sent this in the chat, but I will be really curious to see the results of this benchmark against the Gemini models, especially the flashlight model. It's been for us, it's been pretty like decent for generative stuff, and for search, I would think that is or it would be pretty decent.
Yeah. You can take this this suite, and what I would recommend you, instead of digging through all the code yourself, I would just open in your case probably then Gemini, and would tell Gemini that you would like to add this API, and it will put it most likely in the right place to do so. So it's built to be extendable with other models.
I mean,
Yeah.
in the end, the goal would be to be model agnostic, right? Here for
Yep.
the LM. Yeah.
Sure. But it's good to know, like, if we need Fable 5 to build a query, it's not gonna work, right? But if we can use, I would say that the simpler the model gets that we can use, the cheaper the model gets. It's a cost optimization, the better. Because if you want to run this on the edge where customers can ask questions to your APIs, then you don't want to use an expensive model, right? You don't care if they use it in their own Codex session or their own cloud session, but you would care if you paid the tokens, right?
So we don't really have a control over what model people will use, right? I think we only have a control over what embedding models we can use.
Yeah, exactly. Like maybe the embedding model might be the controllable part. Yeah. I'm not sure, but yeah.
Well, it depends.
Yeah.
Like Meta is looking into using this or is doing this internally. for their developers. So they are in control of everything, the embeddings model, the agent model, and everything. So, but I would agree, like for subschema generation on the fly, it's probably going to be the embeddings model, which is key, and the algorithm. It's crazy how big the difference is between different algorithms that you run. Like if you just do pure KNN, just cosine similarity search or something like this, then you get like a perfect score in less than 20%. So you really have to be creative in how you essentially try to find what's relevant. Because especially with bigger schema, it gets very muddy what's relevant and what's not. Okay, cool. Then we have another thing to share by is it Shelco? Or
It was me.
I was you. Oh,
Yeah.
okay, sorry.
Yeah, let me share my screen. I think we have like 15 minutes. Like a couple of months ago, I shared this with a couple of people, not in this specific meeting, but we started to work on a plugin. We use Apollo Router. So we started to work in a plugin that does mock responses for GraphQL operations, mutations, etc. So it was initially conceptualized as an Apollo plugin, Apollo Router plugin, but the reality is that we don't need to incorporate this functionality in a server. We did it because like Apollo Router is extremely fast. Like I'm not going to talk about Rust. It's blazingly fast, and for GraphQL, I do think that is a perfect match. And for us, we needed to implement it there. So pretty much what we did was an Apollo Router plugin, as mentioned it. But then we decided to open source the thing as a CLI. So the first thing that I want to clarify is that back in that meeting, the solution was proposed as a server, and now it's a CLI. And one of the perfect things about a CLI is that you can incorporate a CLI everywhere you want. It's like the very most granular composable piece of software that you can incorporate in any, let's say, GitHub action, or you can even like invoke it through an npm package. So that's why we decided to do it as a CLI. And models, they like CLIs, right? Especially if you grab your CLI in a agent skill. So you are able to invoke the CLI with natural language. So we open sourced this. It's already published into crates.io, and pretty much the way how it works. I have a Medium blog post that is pending to be approved internally. But for those that are familiar with Apollo Federation, when you're mocking something, it's pretty much the same thing because you're using directives, right? And when you send a request to the mock CLI, you first need to do whatever GraphQL server does, which is parsing and validation, right? Once you do parsing and validation, if you are using monolithic GraphQL or if you're using GraphQL Federation, execution differs. In this case, for mocking responses, we need to do something very similar to query planning. Like I would say exactly the same thing. You grab the operation, you traverse the operation looking for the mock directive field, and the only thing that you need to do is to split the incoming operation in two. The one that is going to go to the upstream GraphQL server, the one that has resolvers and it will return the actual data, and then another operation that is going to go to the LLM in a form of a prompt. So if we put these concepts in a query plan, we are talking about a query plan that is going to consist in a sequence node with two fetch nodes. First is going to fetch the response from the upstream GraphQL server, and then is going to use that response as a context that is going to put in the prompt to be sent to the LLM, so you can get contextual data. And then lastly, similar to Federation, you just need to stitch the responses back together in a single object that is going to be handed back to the client. So here in the GitHub, I have some examples, some GIFs using the Star Wars API from the official GraphQL server. And for example, here we have like this operation. I'm gonna wait for it to run again. But as mentioned, it's a CLI, right? So this is the operation that is going to be sent. It's going to show up in a second. You are querying all the films title, and then you are mocking the opening crawl and the director, and then you just send that to the LLM. The way how the CLI works is that we have a trait that is the LLM bridge. So we have two implementations of that trait. You can invoke your LLM through a CLI, like a code harness, OpenCode, Cloud Code, Codex, Gemini, or you can invoke your LLM through an HTTP bridge, which could be like calling GitHub Copilot. I actually have, so the CLI has multiple subcommands. As mentioned, it is a CLI, it's not a server. I want to make that very clear. It's a CLI, so you can just, it's a CLI that can one-shot GraphQL mock responses, or it also has the subcommand to start a server if you want, but it's optional. So right now I'm just starting the server. This operation, again, the way how it works is that the CLI acts as a wrapper for the upstream GraphQL server, plus a proxy, let's say. So it makes the introspection query to the upstream GraphQL server, and then it decorates the schema with the mock directive. This is our mock directive, the one that we created internally. This is only for GenAI mock responses. I know that there is another mock directive that is sent to the spec, but this one actually only has one argument, which is the hint, which is pretty much the prompt or what you provide to the LLM. So it's different in that sense. So this operation, I'm not sending like any mock directives, but things start to like be interesting when we do something like this. If we translate this again to query planning, we can easily detect that there is going to be one operation asking for title only for the upstream GraphQL server. And then there's going to be a second prompt request to the LLM to mock opening crawl and mock director. And because we use the response of the first GraphQL request to upstream, we can get contextual responses. This is the only response that we get from the upstream GraphQL server. And then the LLM is able to identify that the title is A New Hope. So it's going to mock the opening crawl. And here in the hints, I'm saying that I want to use emojis, for example. So it will mock the data in a contextual way, depending on the response from the upstream GraphQL server. And then you can like just pretty much do whatever you want with it. You can make like more complex operations. Again, mock is only one field, one directive with one argument, hint. That's what is sent to the LLM. And one of the things that we also added is that sometimes you might want to mock fields that are not even part of the schema yet, right? It's pretty common for us, Expedia, that the product developer is working on a new feature that, I don't know, the product manager came up with. And it needs something that is not in the schema yet. So then the whole schema design process starts and everyone is blocked until the schema design is done. But you just want to like quickly prototype something, right? So we start thinking to that problem. And it turns out that in the GraphQL specification, there is this extend type, right? And we use Apollo compiler. This CLI is written in Rust, so we need an implementation of the spec in Rust to do parsing validation and traversal of the operation to extract the fields that are marked with mock. So I have an example for that here in the GIFs here. Schema extension. Let's say I'm gonna wait for the GIF to start again. But let's say you want to extend the type film with a type that doesn't exist yet. So in this case, to MockQL, you are sending two things: the operation GraphQL file and the extension GraphQL file. This is the operation, and it has product brief. And here you are saying that we're extending the type field with product brief and the fields of production brief. So the only thing that we need to do here is before starting the process that we already have implemented, which is parsing, validation, and planning, mock planning, we need to grab the schema that we introspected before and we extended with those types. And Apollo compiler provides that out of the box. So we don't have to do much. Apollo compiler does this teaching for the new fields that you are extending. So this also like provides the capability to like even mock fields that are not part of the schema. And because they're not part of the schema, you don't even have a resolver yet. So we wanted to like do this in a way that can be. We wanted to find a perfect place to put this because I know that I can count 3 companies that are doing mock at the same time. And we wanted to find a place where mock can be placed and reused, right? But everyone's pipeline is different. I wouldn't put this on the client because then you will have to implement, let's say, Apollo client. You will have to look into the Apollo client architecture, and then you will know that you need to implement an Apollo client link, right, for the JavaScript package. But then there's an Apollo client for iOS, and then there's an Apollo client for Android. And then you have to go there and implement the same. I know that it's an spec, but I wanted to like, the whole point of mock is to have something quick, right, to iterate. So if we wait on like implementing specs, it's going to take some time. And the reality is that we just want to get the JSON, right? We just want to get a JSON response. So that's why we thought on a CLI, because 1, agents love CLIs, and 2, CLIs are the most like granular piece of execution that you can just put everywhere. And because it's a CLI written in Rust, it compiles to machine code. So you don't need a virtual machine. You don't need JavaScript runtime installed. It's just machine code that you can just place in your pipeline. This is open source already. We are pending to release this Medium post. And then there's documentation already in place. And I guess we're looking for feedback. And also, like, I think it would be a good idea for the GraphQL ecosystem to come up with something that everyone can potentially use. So that's like the main reason we decided to open source this. And for us, it's been working great. We have access to, like, people work with open code, with Codex, with Claude. So that's why we wanted to provide or give different providers or bridges to the LLM. But for people that loves Cloud Code, then you can use Cloud Code. The CLI is going to invoke Cloud Code programmatically. Same for Codex, same for open code. But if you use, let's say, if you have an Anthropic key or you have an OpenAI key, you can invoke the endpoints directly, and then you will get the response. The benefit is that you won't have the coding harness CLI in the middle, so you are going to get responses faster. Like, for example, if you use this with Cloud Code is a Bun CLI that eats like 7 gigabytes of memory every time you open it. So probably you want to save that, right? You don't want to like just start a new process to mock something. So you just want to make a request directly to the OpenAI server, or maybe to GitHub Copilot, and then Copilot will do a jump to the OpenAI or Anthropic servers. So we have the 2 options. And yeah, it's CLI. It can be grabbed and agents can consume it, and it comes with several commands. I can share the commands, the documentation later, but like mainly like showing this and looking for feedback and see if like there is something that we can come up with, like an effort for. Again, I have counted like 3 companies that are trying to solve the same problem right now. And lastly, and I mentioned it before, for us, mocking GraphQL responses is being exceptionally fast with the Gemini Lite model, the Gemini Flash Lite model. Flash is good, is fast, but Lite is extremely fast, and we don't have to do a bunch of like feedback loops, because at the end, LLMs are undeterministic by nature. Even if we have a prompt that is very specialized, it will hallucinate. So we need to have this feedback loop to like, if there are, we validate the response in other way, in our words. So again, for that, we use Apollo compiler. And the benefit of this is that if it's written in Rust, we have parallelism. We have access to parallel reads to the GraphQL schema. And that's something that you don't have with a JavaScript runtime. Whenever you are reading the schema in the JavaScript runtime and something comes, the event loop is going to wait because you are performing a CPU-bound stuff. And with Rust, we can just have parallel reads, or with other multi-threaded or multi-access programming languages like Java or Kotlin, JVM languages. So yeah, that's what I wanted to share, and hopefully we can come up or happy to contribute what is already like approved, I think, for the mock directive that Mark created. But I do think that this, in my humble opinion, this is more suitable for a CLI. And it has to be, depending the need, but it has to be something that can guarantee concurrent access to the GraphQL schema, which is something that a JavaScript runtime won't give you. You can use workers, but you will have to clone the schema for every worker. Yeah, that's pretty much what I wanted to share, and just open to answer any questions.
Very cool. Very cool.
Thanks.
There's some conversation in the chat. Looks like might be worth pulling that out into. Well, I realize that we're beyond time, so maybe it's a topic for next time. But just real quick, a summary of kind of the distinctions between this model and the GAP model as well that that Mark was championing.
Yeah, I guess
Might be worth just a
would be-
quick chat about that.
it would be interesting to hear about Mark's and Michael's thoughts, because they essentially have done something very similar. And like from the conversation in chat, it seems like that there is collaboration potential, which we probably can or should make use of.
Yeah, since we're at time, maybe Samuel, are you in the Discord? Maybe we could
No.
use that. There's a couple threads
can-
on it in there.
Yeah, I can download Discord and set that up.
Cool. Yeah, maybe we can chat there. There's a AI-WG channel there, and there's a couple threads on @mock. So maybe we can collaborate offline throughout time.
Would you be willing to have a discussion about this next working group? Because then we can now lock it in, and then you have enough time reserved for it to discuss. Just don't make the same mistake that I did and put it into the wrong agenda. So just take the right one, and then it will be there next month.
When is the next?
Next one is actually calendar.org.
July
July
23rd.
Yes, exactly.
Okay.
Of course, like the Discord is something for you to anyway communicate, but I guess it's interesting to either have a discussion or see the results of your discussion next working group.
Cool.
Yeah.
Is there I need to look into the chat, Zoom chat. Is it going to be lost after this meeting ends, or we can export it? So I can look into it.
You can download it real quick, but I think it does get lost. There's like a ... and then save chat.
Oh, save chat. Okay. Okay, perfect. Yeah, I just did. Thank you.
If just real quick, Samuel, if next week, next month, whatever, doesn't work, we have the ability to spin up like an ad hoc instance of this working
Yeah, we don't have
meeting.
to wait a month. Yeah.
Yeah, in fact, probably I'd be down to chat like next week or something even.
Yeah.
So let's get in Discord and kind of figure out time for that. And I don't know that I've actually done that yet, but Benji knows how. So yeah, we'll spin up like an official ad hoc instance of this working group meeting, and it'll be on the calendar and everyone can attend and all that.
Yeah, I'll set up Discord, but how we can like keep in sync before I do that? Because
I
I
think-
sent an email earlier and I didn't get a response. Yeah.
LinkedIn, email, I think we're all connected on email.
Okay.
But yeah, you can also just search GraphQL Discord. We have like on graphql.org a page on community, and then you can just make a Discord account. That's the best way, because I think we're all in Discord. And there's if you go to the Pound Gaps channel,
Cool.
I'll email you. Yeah.
Cool.
Awesome. Yeah, I'm hoping we can collab on this, because it does sound like there's multiple interfaces perhaps on the same kind of core gubbins.
Yeah.
I'm hoping.
Yeah, and I would love to hear like the constraints that you guys have found, because I'll tell you, like, just to wrap up this really quick. Just 2 days ago, I came up with a problem where where the LLM struggles with mocking abstract types. So we are forced to include the type name introspection field, and then on MockQL programmatically we have to trim that out. I don't know, the way how this assembles to federation is remarkable. I think it's pretty much the same thing. It's exactly the same thing.
There's two parts to this. There's like the generation and user interface side, and then the sort of like how we merge in the responses and how and where that lives. And like that's the sort of like really tricky complex bit that I don't want people vibe coding because they can get wrong. My ideal thing is that we provide a spec that all of the like as a Joe Schmo user just spinning up a GraphQL client, it should just be like an off-the-shelf thing that you can install a framework plugin, or it comes default out of a framework. And so the example that I've got for our thing is the spec is implemented as an Apollo link for web, and also a Relay plugin implementing the same spec, so that you're not implementing the spec, you're just kind of like installing a plugin, and all of the like complexities of this is shared. And then on the other side of it, on the developer facing side of it, on like the complexities of what you just said about dealing with abstract types and all that, like that's a little more controllable. But we're already so over time, I guess, so let's continue this next time.
Just one last thing that I wanted to clarify. This is not a server. Like, you are seeing a graphical interface because I am starting the MockQL CLI with the proxy command.
I think we're all agreed there's no server involved. There's no need for a server. I think we're all agreed. I'd love for I think I've already kind of made this clear, like the ultimate what's what I'm looking for, like my evil mwahaha plan is that we can convince like the Apollo folks and the Relay folks as well, I guess, that like this is a common enough problem, and that like we can have an Apollo link and a Relay plugin and all that, so we're not reinventing the wheel like 1,000 times on this. A lot of people clearly have this problem, so
I said 3 companies, but it's actually 4. Cool.
Alrighty, cool. All right, catch you next time.
Yeah, thank you all.
All right,
everyone.
see you then.
See you later, guys.
Bye bye.
Thank you for joining. Bye.